Jai Hind to all of you. I am Priyanka Sharma, Assistant Professor AC Department, AKGEC. I am going to present my video lecture in Fundamentals of Electronics Engineering BC 101. So, in this lecture, I am going to cover up the topic of Unit 5, that is Fundamentals of Communication Engineering. So, let us know about first of all the content, what we're going to cover here. The content of this lecture will be, we will going to study about the numericals regarding the fundamentals of amplitude modulation. Then we are going to study about the modulation techniques, fundamentals of amplitude modulation. In that we had studied about the amplitude modulated wave equation, that is amplitude modulated wave equation. We have this amplitude modulation equation is given by the formula, that is, we have carrier part, that is AC cos of omega ct, plus we have, this is called the carrier component, and the other component is mu AC divided by 2 cos of omega c minus omega m t, that is the lower sideband, this is the LSB, plus the another component is mu AC divided by 2 cos of omega c plus omega m t. This is the upper sideband component. So, these are the three components which we had studied in amplitude modulated wave equation. Amplitude modulated wave equation. So, in this equation, we had already derived the formula for the total power. So, the total power which is to be transmitted in the amplitude modulated wave is given by the formula. We are going to see here, we have this amplitude modulated wave equation, this I had already told you, this is given by this formula, and it is represented in the linear frequency component like Fc plus Fm or Fc minus Fm. So, this creates the upper sideband and lower sideband. So, if let us suppose this is carrier frequency, this will be the lower sideband frequency Fc minus Fm, and this will be the upper sideband frequency, that is Fc plus Fm. So, in this amplitude modulated wave, we had studied about what is total power. The total power is given by the sum of carrier power, upper sideband power and lower sideband power, and these formula can be calculated by substituting their respective values. So, carrier power is actually given by Vrms square divided by R. Vrms is the voltage RMS value of the carrier and R is the load resistance of the antenna. So, if RMS value you want to calculate, RMS value is given by the formula Vm by root 2. So, we will going to calculate these power for different components, carrier, upper sideband and lower sideband. So, this we had already calculated, and this can be written as, for carrier power we have derived the equation AC square divided by 2R. For upper sideband we have amplitude AC mu divided by 2, and for lower sideband also we have amplitude AC mu divided by 2. So, by taking these amplitudes we can calculate their RMS voltages AC mu divided by 2 divided by root 2, and from that we can obtain the upper sideband power, which is coming out to be AC square mu square divided by 8R. And after that, this is same as lower sideband power because the amplitude is same. So, we will get the same power AC square divided by mu square divided by 8R. So, the total power is obtained by summing all three components. So, by summing all three components, we will arrive at the equation of the total power of the amplitude modulated wave, which is given by Pc multiplied by 1 plus mu square divided by 2. And this Pc is given by, this carrier power is actually given as AC square divided by 2R. So, in this way you can calculate the total power. So, this formula we had obtained. So, on the basis of this formula we can study about the numerical analysis. So, first of all, before that we are going to also see about the power spectrum of the amplitude modulated wave. So in terms of power, if we see it, we have at carrier frequency, we obtain the power as EC square divided by 2R, and for the upper sideband we have the power m square PC divided by 4, and for lower sideband we have again m square PC divided by 4. So these are the two powers of lower sideband and upper sideband frequencies are obtained. Now next, if we talk about the numerical problem regarding the amplitude modulated wave, let us take this example. In this question, we have a modulating signal. A modulating signal mt is given here, and this is given expressed as the equation 10 cos 2 pi multiplied by 10 to the power 3t. Modulating signal we have represented as mt, and this can be written as 10 cos 2 pi multiplied by 10 to the power 3t. And we have the standard equation for modulating signal as this. After this, this is amplitude modulated with carrier signal. That means carrier signal is given as 50 cos 2 pi multiplied by 10 to the power 5t. So in this question, we have to find the modulation index, that is mu, or we can say m. We have to find the carrier power PC. We have to find the power required for the transmitting AM wave. That means you have to find the total power of amplitude modulated wave. So this is MT we have given here. By comparing this with the standard equation, we will obtain AM as 10 and FM as 10 to the power 3. So AM will be 10 volts, FM will be 10 to the power 3, that means 1 kilohertz. Now after this, with the carrier signal we have given, again comparing this with the standard equation of carrier signal, we will get the carrier amplitude and we will get the carrier frequency. So from this, the carrier amplitude we get 50 volts and the carrier frequency is 10 to the power 5, that means it can be written as 100 kilohertz. So from the formula of modulation index, we can find mu as AM divided by AC. So by substituting the value of AM and AC, we can find the modulation index, and it is coming out to be 0.2. So this will give you the value of modulation index. The first part of numerical will be calculated, and if it is represented in terms of percentage, this can be written as 20%. That means 0.2 multiplied by 100. It is coming out to be 20%. Now next, if we want to find the carrier power, this carrier power can be calculated by the formula EC squared divided by 2R. So we can substitute all this value by assuming the load resistance of antenna as 1 ohm. You can substitute any value. I am taking this as unity value, that means 1 ohm. And we have carrier amplitude given. So by substituting the value of carrier amplitude and load resistance, we will obtain the carrier power as 1250 watt, 1250 watts. So this is the carrier power obtained. Now next we have to find out the total transmitted power for the AM wave. So the total transmitted power equation is given by the formula PC multiplied by 1 plus mu square divided by 2. So we already had calculated PC, so we will going to substitute the value of PC. We already had calculated modulation index, we will substitute this value, and again we calculate this, we will obtain the value of power as 1275 watt. So this is the power required for transmitting the AM wave. So this is one part of numerical analysis of amplitude modulated wave. Now next, we can again take one more question for that analysis of amplitude modulated power. So again we have an equation of amplitude modulated wave which is given in this form in this case. That means ST is given by this formula. So this is another type of equation or another type of giving the numerical equation. So this equation, if you find out, this is ST equals to 20 multiply by 1 plus 0.8 cos of 2 pi multiply by 10 to the power 3t cos of 4 pi multiply by 10 to the power 5t. This can be rewritten as in this way. You can write like this, because we have omega equals to 2 pi f. So for standard form we have to separate the 2 pi. So we will going to separate the 2 pi here. Now after this we will going to compare this given equation with the standard equation of amplitude modulated wave. This we had studied in the very first basic concept of amplitude modulated wave equation. So this equation is basically given by this formula, that is AC multiplied by 1 plus mu cos of 2 pi fmt multiplied by cos of 2 pi fct. When we compare these two equations, we will obtain first AC as 20. So AC is coming out to be 20 volt, and by comparing these two we will get mu as 0.8, and again if I compare this is corresponding to FM. So FM is coming out to be 1 kilohertz, and by comparing these two, FC is coming out to be 200 kilohertz. So this is one part of analysis. In that we had compared the given equation with the standard equation, and we obtained the given parameters. Now after this again we have the same type of calculations which we had done with the earlier question. So in this also we have to calculate what we have to calculate. We have to calculate carrier power PC, we have to calculate total sideband power, that means we have to calculate sideband power, and after this I have to calculate bandwidth also. I have to calculate bandwidth here. So the way of asking the parameter is different here, but we will going to proceed in the same way as we had done earlier. So first we will going to calculate the carrier power. So carrier power is given by this formula, same formula, AC square divided by 2R. Again we will going to assume R as 1 ohm. By substituting the value of AC and R, we will going to obtain the power as 200 watt. So this carrier power is obtained as 200 watt. Now I have to calculate the total sideband power, but I know the single sideband power, LSB power, is given by the formula PC mu square divided by 4. So this is equals to upper sideband power also. So if total sideband power need to be calculated, this 2 will be added, or this can be 2 times. So if we make it 2 times, the power obtained for total sideband will be PC mu square divided by 2. So this is given by this formula. Again by substituting all these values, PC as 200, mu as 0.8 whole square divided by 2, we will obtain the total sideband power as 64 watts. So this we had obtained. Now the last we have to calculate bandwidth of the EM wave. Bandwidth is basically given by the formula 2FM. This I had already explained you from this spectrum. In this spectrum, this is called the bandwidth, and this bandwidth is given by, basically bandwidth is given by upper sideband frequency minus lower sideband frequency. So what is upper sideband frequency? This is FC plus FM minus FC minus FM. This is the lower sideband frequency. So it is obtained as 2FM. So by substituting this formula, I can obtain the bandwidth 2FM. So it is coming out to be 2 kilohertz. So this is these are the few examples of numerical analysis which we had did on the amplitude modulated wave equation. Now next we are going to discuss about the generation of EM wave. Till now we had studied the basic concept of EM wave. In this we have studied about the equations, how the amplitude modulated will be transmitted, and what are the content of power we have to transmit. Now after this we want to know about the circuitry which is going to transmit this wave equation. So for that purpose we had made different type of circuitries. Basically we have two type of circuit, one for modulation and one for demodulation. So for the modulation purpose, we have basically two types of modulators. One is square law modulator and other is switching modulator. So these are the two types of modulators. In any way we can modulate the signal. The main motive is to generate the AM wave equation which we had studied in the fundamentals. So this is the AM wave equation we need to be generated. So in this we have the first method we are going to study is square law modulator. So square law modulator, as the name specifies, we are going to square the signal. So we will make some arrangement of the circuits by taking different type of electronic components. So this basically shows the block diagram of square law modulator. So in this, first of all, we have message signal MT, and we are going to add up this message signal with the carrier signal input, that is AC cos of 2 pi f c t, and by summing this, we will obtain one output which is one V1t. But this is not the actual amplitude modulated wave equation. So to generate the actual amplitude modulated wave equation, which is of the form ST is equals to, this is actually of this form, we have to modulate the carrier amplitude, we have to modulate the carrier amplitude, with this, with the message signal, and this whole signal will be transmitted according to the carrier frequency signal. So this can be written like this. That means you have to obtain this equation. So by summing these two, we cannot exactly get this equation. So for getting this exact equation, we have to first square this intermediate equation. So for that purpose, we have to connect one square law device. This will going to do the squaring of this input in a equation form. Then after this, that we will get again another equation V2t. So this square law device will do the squaring on by using one equation. V2t is actually given by V2t is equals to K1 V1t plus K2 V1 square t. So this will do the squaring with this method, with this equation. So this is the equation if we follow, and after that we will get the equation which contains number of components containing some FM frequency components, some FC frequency components, some 2 FM frequency component, some 2 FC frequency components. So for getting only the required frequency component or the message component, we will going to pass it through the band pass filter. So this band pass filter will going to transmit only the message frequency component. So going to transmit only the carrier frequency component. So this frequency component we can obtain by passing it through the band pass filter, and we will going to obtain the required modulated wave equation which is given by this equation. So this is the functioning of the square law modulator. After this, we have to detect the signal. That means demodulation of the AM wave. What is demodulation? Demodulation is the process of extracting the original message signal from the modulated wave, and this is known as detection or demodulation. So for that purpose also we require some circuitry, and that circuit which demodulates the modulated wave is known as demodulator. So similar to the modulator circuits, we have different type of AM demodulators. Corresponding to square law modulator, we have a square law demodulator also, and one more demodulator circuit, that is envelope detector. So one by one we will going to study this. So we have square law demodulator which works on the same functioning as that of the square law modulator. So, square law demodulator is used to basically demodulate the signal, and this is the circuit of the square law demodulator. In this, we have an input signal as a AM wave, we have a modulated wave which is given as V1t here. This is given in the form of V1t equation here. Again, in this case, it is passed through the square law device, and we obtain here again another set of equation, another set of output, that is V2t. And it is after that it is passed through the low pass filter. This block diagram is shown here. It is passed through the low pass filter. Here we had used the low pass filter instead of band pass filter, because in this case we want to recover the original message signal, and message signal is a low frequency signal. So that's why we want the low pass filter. This will going to filter out the FM frequency component. 0 to band of frequency that will filtered by the low pass filter is 0 to FM hertz frequency. So demodulated output is obtained after this low pass filter. So this low pass filter is actually consist of RC circuit, and after this we will get the output. So the methodology or the basic concept is same behind the demodulator circuit also. In this case also we will going to, after first amplitude modulated wave is given here, which is in this is same as ST. The V1t we will assume it is same as ST, which is given by the formula AC multiplied by MT 1 plus MT, and this is transmitted as cos of omega CT. So if we going to give this input here in the square law device, we will going to obtain V1 as AC 1 plus Km MT cos of 2 pi f CT. So this can be written like this. Now after this, if we put or pass it through the square law device, the second set of equation V2t, as I already told you, this device performs the squaring operation in this equation form. So K1 V1t plus K2 V1 square t. So if we will going to substitute V1 value here and try to solve this mathematical equation, we will obtain this set of components. Among this set of components V2t, if we going to rearrange this, we will get this equations. But among all these components, we have to recover only the message signal. So from all these signals, we have MT present in this equation only. Remaining equation contains frequency component, carrier frequency, somewhere it is twice carrier frequency. So we have to only recover the single message frequency. So we are going to recover this equation. So after that, from this term is the message signal. So we are going to extract this signal by passing it through the low pass filter. So we will obtain the original signal from here, and remaining components will be eliminated. That means how this we had studied here, how this demodulator is working. So similar to this, we have another type of demodulator, that is called detector. One is called square law demodulator and another is your envelope detector. And envelope detector is also used to detect the AM wave, and it again separates the message signal from the high frequency carrier signal. So this works on the basis of, in this we have an input wave, AM wave, and it is passed through the diode here. That's why it is called as envelope detector. In this I am passing it to the diode. So it will going to forward bias when the signal will be positive, and it will be reverse bias for the negative signal. So only for the forward bias it passes the signal. So we have only obtained we will going to obtain only the positive envelope from here. So positive envelope is again passed through the low pass filter. Here only the message signal will be filtered out and obtained at the output portion. So this envelope detector basically consists of diode and low pass filter, and diode is the main detecting element as I told you. Hence, the envelope detector is called as the diode detector. And the low pass filter here contains is a parallel combination of resistor and capacitor. And the capacitor working will be going to recover the message signal. So if we going to analyze it mathematically, we have AM wave equation ST with AC 1 plus Km MT cos of 2 pi f ct. So it will going to work as, when we apply the signal, the positive half cycle of the AM wave, the diode conducts and capacitor is going to charge to the peak value of the AM wave. Suppose we have this equation, if we see diagrammatically, we have this amplitude wave like this. So we have contained, this is ST we have obtained, and in this ST, this envelope contains the message. So this message signal can be recovered by charging of the capacitor. So first of all, if it is passing through the diode, if we will pass it through the diode, diode will be forward biased only for the positive cycle. That means it will going to detect the positive cycle, or we can say positive envelope. The negative envelope will not going to be detected. That means negative, and in a negative cycle of the modulated wave, diode will be reverse biased. So for the positive envelope, or we can say positive envelope means upper sideband, diode will be forward biased. Diode will be forward biased. So it will be conducting, and we will obtain the output as the positive envelope. So this positive envelope will be obtained. After that, it is passing through the capacitor. If we put one capacitor here, if we put the capacitor here in parallel combination with the resistor RL, this capacitor will going to charge after this diode for the peak value of the message. So it is charging from lower value to peak value. After this lower value, again it is charging from lower value to peak value. So in this way, we obtain the original message signal in the output side, and this has a frequency. This has a frequency of FM. So how this is how the envelope detector works. So this is written here कि when the AM wave is less than this value, the diode will be reverse biased, and for the positive half cycle of the AM wave, diode will be conducting, and accordingly capacitor charges to peak value of the AM wave. Thus, the capacitor will going to discharge through resistor R till the next positive half cycle of AM wave. When the value of AM wave is greater than the capacitor voltage, diode conducts and process will be repeated. So this is how we had seen how the detector will going to work. So in this lecture, we had studied about the power calculation of the AM wave, modulation technique and demodulation technique.